Hi, you guys. I'm sorry I'm a day behind on these. I am working to get caught up on everything. It's, I guess, kind of been blindsided by this whole situation of not being on campus. So I'm going to try and get us a day ahead. Let's see how that goes. Today's lesson is going to be covering something called inverse functions. So let's get a better idea of what that means. Inverse functions are so it's pretty much just the opposite of whatever function we had. So let's look. This is lesson 1.3. If we were in school, this would be block day 2, or you could put the date, so 9/8 or 9/9, whatever day you would have been here. So let's look at what we would call a function. A function is something where we have one output for every input. So each input has one output. Let's say each input has only one output. Each input has only one, that's a 1 right there, output. An example, so I'm going to show you a couple of examples here. I'm going to show you one that is a function and one that is not a function. So something that is a function would be like, so say I gave you the XY table and it had just the random numbers on it, 1, 2, 0, 1. The outputs that correspond to these would be, so let's say for this one we get out a 3, for this 2 we got out a 5, for this 0 we got out a 1, and for this one we got out a 3. So you want to look to see, is there any numbers that are repeated in the input? So 1 is repeated in the input column. Do we get the same output? So yes, we do get the same output. So this would be a function. If you look at this next example, so we have the XY table. So let's say our inputs this time are 5, 6, 5, 7. So for this 5, we have an output of 2. For the 6, we have an output of 4. For this 5, we have an output of 1. And for this 7, we have an output of 6. So again, we look to see, are there any repeated inputs? The 5s are repeated. Do they have the same output? So no, they don't. So this one is not a function. So is a function, and then we'll just say is not. FNC function. Okay. So roughly that's what a function is. Now if we look at an inverse, so inverse function, you just say inverse. An inverse is where we switch our input with our output. So you're just switching the two values. Switch your x for your y. So in parentheses I'll say x goes to y and y goes to x. So if we were doing a transformation, that's what it would be. So let's look at an example of this. We have the XY table. 1, 2, 0, 1. And the output is 3, 5, 1, 3. So I just copied that table that I had right up here. So the inverse of this function, I'm going to call this function, we'll call it y to the -1. So the values that we would plug in are we're just going to take this y column, or sorry, row, and just insert it up here. So 3, 5, 1, 3. And now you just write the corresponding x values. So the corresponding x values would be this 3 has a 1, the 5 has a 2, the 1 had a 0, and the 3 had a 1. So now we have this as our new inverse function. So this is the inverse of this. So this is the inverse of this. And that's the whole thing. All right. Let's look at an example in the book. So example 1 from the book. A, so there's an A and a B. Example 1A has a list of coordinate pairs. So -4, 7, -2, 4, 0, 1, 2, -2, 4, -5. If you were to take and write the inverse function of this given set, all you do is you switch the x and the y values. So our answer would be 7, -4. So that first point, the inverse of it would be 7, -4. So then you just switch all the points in all of these. The next point would be 4, -2. And then 1, 0. So we're just switching. -2, 2. And then our last point would be -5, 4. So that's just the answer. This is just the inverse. For B, we had a table. So they call it the input. And then instead of y, it's called the output. So they set up this table. We have -1, 0, 1, 2, 3, and 4. The numbers that correspond to these are 5, so in the same order, 5, 10, 15, 20, 25, and then 30. So now to get the inverse of this table, all we do is switch the input and the output. We don't switch the names of them. We just switch the information in the table. So it's still called an input and an output. We're just switching the information in the table. So instead of writing this -1, 0, 1, 2, 3, 4 in the input spot, we're going to put it for the output. So -1, 0, 1, 2, 3, 4. And then our inputs are going to be 5, 10, 15, 20, 25, and 30. I apologize for not putting lines between those numbers. All right, it's fairly simple when we're given this type of an example. If I asked you guys to look at problem number 1, so problem number 1 is another set of points, and it asks you to take the inverse of these points. So -3, 4, -2, 0, -1, 4, 0, 8, 1, 12, 2, 16, and 3, 20. So if you took those points and wrote an inverse, there's going to be a second problem. So input, so this time we have an XY table, output, but all I wrote was put. Okay. And then for our table, our input row is going to be 4, 1, 0, 1, 4. And the output would be -2, -1, 0, 1, 2. All right. So I want you to pause the video and try these two problems. When you unpause, I will show you the answers. So the answer for this one should be 4, -3, 0, -2, 4, negative 1, 8, 0, 12, 1, 16, 2, and then 23. After I wrote this, I realized I gave you the answer, but if you switched it, you'd still get the same thing. So the new input would be output. That's a hard word to spell, and it's only 6 letters. So the new input would be negative 2, negative 1, 0, 1, 2, and the output would be 4, 1, 0, 1, 4. Not too difficult. So moving right along, we are going to look at example 2. So example 2 says find the inverse. Example 2, find the inverse. So now we are going to be looking at actual functions and finding the inverse from that. We're not just given a point or a table. So if I give you the function f of x equals 2x plus 1, it's a linear function, so it's not something super complicated. But to find the inverse, it just means that we're going to solve for x. So find the inverse, in parentheses, I'm going to put solve for x. All we want to do is solve for x. So the way that we start is by switching this to a y. So we switch that f of x to a y. It's just a little bit easier to deal with a y than it is to deal with an f of x. So y equals 2x plus 1. They essentially mean the same thing. It's a linear function. And now we are going to solve for x. So we want to get x by itself. We want to isolate this variable. We take and subtract 1 from each side. So we have y minus 1 equals 2x. From here, divide everything by 2. So that equals 1. And then we have y minus 1 over 2, which is what x equals. So that's it. That's the inverse function. I want you to try the next 3 problems. So 3 is the f of x equals x minus 6. Number 4, and these are in your book. Number 4 is the f of x equals 1/2 x plus 3. And then number 5 is the f of x equals 10 minus x. So now for these, I want you to remember that you are just solving for x. That's all we're doing. So replace the f of x with a y and solve for x. So go ahead and pause the video, and when you unpause, we will go over the answers. So for this first one here, if we replace the f of x with a y, we just have this simple thing where all we have to do is add 6 to both sides. So now our new function, our inverse function, is y plus 6 equals x. For number 4, if we start by subtracting 3 from both sides, I forgot to change that to a y, so we get y minus 3 equals 1/2 x. Multiply everything by 2, so we get 2y minus 6 equals x. For number 5, if we first replace that with a y, we end up with this, and you could do a couple of things. You could move the x over to make it positive, or you could just switch the sign of everything after we're done. So we'd have y minus 10 equals negative x. Can't have a negative variable, so we switch the signs of everything. Negative y plus 10 equals x. And that's our inverse functions. So then the next part of this problem in the book said to evaluate it when the output is 4. So they want us to plug 4 in for y for all 3 of these and see what outcome we get. So if we substitute a 4 in here for y, 4 plus 6 equals x. 4 plus 6 is 10, so x would just be 10. For number 4, if you plug a 4 in, we have 2 times 4 minus 6 equals x. So 8 minus 6 equals x. So x would just be 2. And for number 5, we have -4 plus 10 equals x. So the -4 plus the 10 is going to give us a 6. So again, not super complicated, but it's a little different to think of x being our function, our linear function. But I mean, really, if you think about it, it's just a reflection. And there is an example in the book of what I mean by a reflection if you look at the line being reflected across another line. So we will go over that in example 3. Example 3, let's see, we have the f of x equals 4x minus 9. So just find the inverse of this function. Just solve for x. So y equals 4x minus 9. Add 9 to both sides, so we have y plus 9 equals 4x. And then from here, divide everything by 4. I like to just write my answers as a fraction. I don't care if it's a big fraction, but it's easier. There's less room for error that way. There are 3 problems that I want you to try that go with this. So I'm going to write those 3 problems down. For number 6, we have the f of x equals 6x. For number 7, we have the f of x equals -x plus 5. And then for number 8, we have the f of x equals I keep saying negative. The f of x equals 1/4 x minus 1. Okay, so go ahead and pause the video and try these 3 problems. You are just solving for the inverse. So you're just finding the inverse function. For number 6, to find the inverse function, you should have divided everything by 6. So y equals 6x, you just divide everything by 6, and we get that that is our new inverse function. For number 7, first we would add everything to, subtract 5 from everything. So then we have y minus 5 equals -x. Can't have a negative variable, so we switch the signs of everything. -y plus 5 equals x. And then for number 8, we have y equals 1/4 x minus 1. I would start by adding 4 to both sides. Adding 1 to both sides, wow. I'm jumping the gun here. And then from there, we multiply everything by 4. So to get rid of the fraction, we multiply by the denominator. So multiply everything by 4. We get 4y plus 4 equals x. And that is our inverse functions. So your homework that goes with this video is going to be found on page 23. It is going to be numbers 3 through 21 odd. So that means 3, 5, 7, 9, and so on. I hope you have a wonderful day, and that next video will be on time, I pinky promise.